Number 7. In figure 16.8, all of the possible distributions in microstates are shown for 4 different particles shared between the 2 boxes. Determine the entropy change, which is delta S, for the system when it is converted from distribution B to distribution D. Okay. So when we're talking about delta S values, right, entropy, randomness of molecules, and microstates, there's only one equation that comes to mind, which is this equation right here. Delta S equals K times the ln of Wf divided by Wi. Now the delta S is the entropy change. Remember that we've seen that delta, right? The delta, the triangle, means the change. So this is the change in entropy, the randomness of molecules. K is a constant value. This is the Boltzmann constant. So just has to be memorized. 1.38 times 10 to the negative 23rd. And the units for the Boltzmann constant is joule per Kelvin. That's why your delta S values, when using this formula, are also joule per Kelvin, because it's based off of the Boltzmann constant. Your microstates have no units. So it kind of makes sense that whatever the K value is, the delta S is the same. The delta S is the same. What are your W values? Well, your W is your number of microstates. And a microstate is the individual pictures. So for right now, I circled 4 microstates. Here's one microstate, right? So it's just basically the pictures. We just want to know what the microstates are. F for final and I for initial. Well, let's see, right? Now, here's the picture for figure 16.8. So we're going to be using, obviously, this one for this question. Now, it says that we started, right? It says that this system was converted from distribution B. So that seems like that's the initial. So let's see. Distribution B, here's distribution B. How many microstates are in distribution B? 1, 2, 3, 4. So there's 4 different microstates for distribution B. So this one is going to be a 4. Final, we're going to distribution D. That's the final. Well, here's distribution D. How many microstates? 1, 2, 3, 4. Oh. So no change here. We started with 4 microstates, we ending with 4 microstates. Did we change in randomness, right? Well, no, because we started with 4 and we ended with 4. We didn't gain anything, we didn't lose anything. So let's just see what that change in entropy is if we didn't lose or gain anything. You might have a feeling what it is. Delta S equals 1.38 times 10 to the negative 23rd times the ln of 4 divided by 4. Plug it into Calci. I'm going to do it all in one shot. Let's see if we get the same answer. ln of 4 divided by 4 is 0. And if you times it by the Boltzmann constant, this would be 0 joules per Kelvin. And it kind of makes sense. If you start and end at the same number of microstates, you didn't gain any randomness, you didn't lose any randomness. So the change in entropy was nothing. There you go. I hope this helped. Let me know in the comments. Thank you so much for reviewing the video. If you would like to help us out, please press the subscribe button. We're almost at 20,000 subscribers, and it's all because of you guys. So thank you so much, and I will be talking to you in the next lesson. Okay, bye.